Hey everybody, and today we're going to be doing polynomial division. I didn't really have a plan. Not a lot of fun math to do, so, or at least the fun ones I'm not smart enough to solve. So instead we're doing polynomial division. So let's do it. We have 4x cubed minus 12x squared plus 5 over x squared plus 3. So we're going to do our little division table here. And the idea behind polynomial division is, well, pretty simple. Similar to long division in that when we do something like, say, 181 over 2, we think of, okay, how many times does, 2 go into 181? We know 90 times 2 is 181, so we have at least part of our answer being 90. And then when we do 2 times 90, I'll write it over here, 181 minus 180, that's equal to 1. Now 2 doesn't go into 1 at all, because 2 is bigger than 1. So instead, we would just do 1 over 2, and we add that to our answer, 1 over 2, and we get 90.5 as our answer. 1 is our remainder, so we just put that over 2, and we get our answer of what 181 over 2 is, using long division. Now, that's all cool, but when we do polynomials, it's a little harder, but the idea is still the same. So let me just write this down. 4x cubed minus 12x squared. Now, when we do polynomial division, we always want to have every degree, or rather, from the highest degree descending down to our constant, we want to have all those powers. So because we start off at degree 3, or cubed, we have degree 2. However, we're missing that just simple x term. It should just be some x. So I'm going to substitute in a 0x, because this isn't going to change the value of our equation. 0x is still 0. But we can do this to make the division a little easier, and then we can add our constant, 5. Now the idea is still the same. However, we don't include the plus 3, we just ask, how many times does x squared go into 4x cubed? Well, we know 4 times x squared is 4x squared, and an x squared times an x becomes x cubed, so we would say, not here, but I'll do it over here, let's do 4x x squared goes into 4x cubed 4x times. So now we multiply these out, we get 4x cubed. Now we're going to subtract. And with polynomial division, you always want to think of it as adding the opposite. So similar to synthetic division, you're always adding the number. So if the number you're trying to subtract from is a negative, and what you're doing is adding a negative, you're not going to cancel out that number. You're just going to make it more negative. So remember that for, signs and whatnot. It does get a little annoying, but whatever. So now we have 4x cubed, and then we have 4x times 3. That gets us 12x. Now, because it is just a 12x and not a 12x squared, we cannot put it under the minus 12x squared. Instead, I'm going to put it under this 0x. Now we do our subtraction. These terms cancel out, and we're left with minus 12x squared minus 12x plus 5. Now we do that again. We look at negative 12x squared, and we ask ourselves, how many times does x squared go into that? Well, that's obvious. It's just, we do a minus 12. There we go. So we get, once again, just match these signs because we're always adding the opposite. So when this becomes minus 12x squared, we're actually adding the opposite, which is just positive 12x squared. So we add 12x squared here. And now we look at negative 12 times positive 3. That's negative 36. Once again, adding the opposite. So we actually add 36. We do it again. This cancels. We're left with this negative 12x and plus 41. I'm running out of space here, but that's fine. Now, x squared doesn't go into 12x at all using just positive integers. We could go into negative integers, but you know, it's a little muddy in the waters there. So instead, I'm going to leave this here as our remainder, because x squared doesn't go into minus 12x at all. So in conclusion, our answer is actually, we bring this similar to how when we have a remainder in long division. In this case, we're going to have this here as well. So minus 12x plus 41. But just like in long division, we would have it over our divisor here, which is x squared plus 3. So this is our answer. Now, if you were to have no remainder, that means your divisor is a factor of that polynomial, which makes things a lot easier, but you're not going to have that all the time. Yeah, that's quick, easy, long polynomial division problem. I might make a synthetic one later, but, you know, that's if I feel like it. It's just really boring, really easy. Thank you for watching.